Okay, this one is they're studying people that are actually getting a divorce, um, but the years of courtship versus how long the marriage lasts. Now, I only dated my wife for about a year before I asked her to marry me, so I'm like kind of up in this range, probably an outlier of some sort, but we're still married, so we wouldn't be part of this study. Anyway, this is how you would describe this: moderate, strong, positive, linear relationship. That's all you got to do. Yeah, put that in a sentence in some way. Make it sound nicer than that. Here's the next one. So what do we got? If we had a new point, 4.5 and 8, so 4.5 and 8, which is right there. Oop, let me put a dot there. Something like that, right there. So that does look like an outlier based on kind of the trend. If you were thinking about the least square line, that would probably be some sort of an outlier. And let's see, what effect would it have on this new point on the correlation? Okay, it would decrease the slope of the linear regression line for sure. Okay, that's what it would do. And you might also want to put that if you put that point in there, it would also decrease the correlation. So like that R in your calculator would change from, say, a 0.91 to a 0.85, something like that. Okay, so those are the first two in the free response. So let's go to number 13. Okay, here's the next piece. Now, don't forget, so this is the area we're really concerned about right now. So let's see. This is the y-intercept. This is our slope right there. I actually do give the r squared and the r for how closely they are related. I wonder if that comes up later. Anyway, so slope of the regression line is right there, 2.4559. So what does that mean? Interpret it in the context of this problem. Well, for every year that you're married, the prediction is that, for every year that you are courting or dating your spouse, that adds 2.45 years to your marriage. I better say that again. For every year that you increase your courtship time, your marriage lasts 2.455 years longer. Okay, so that is the trend with this group of people. All right, let's go to number 14. Okay, this is a little tricky. We didn't really talk too much about this, but some people knew it in class. I heard them say it. This is the standard deviation of the residuals. So how far are we off? Well, standard deviation always tells us the average amount that we were off the regression line. So this is how far we are away from the line on average. Okay, there's that. Okay, for this one, I don't know if it's really common sense, but if you look at it, you just say, well, these open squares are people that have kids. So it tends to look like their marriages are lasting longer. And it seems like they were dating longer. That's courtship. Okay, longer courtship, longer marriage if you tend to have kids. Okay, there you go. And it looks like they're kind of closer to that regression line as well. Not quite as much variance. Okay, let's go to number 16. Okay, on this question, they give you all the information that you need. Now, here are the formulas. This is how we figure out what B is, right? There's R. We're just going to plug them in, right? There's the R. The standard deviation of Y right here goes right there. Standard deviation of X goes there. Crank out that number. That's B. How do you figure out what A is? Well, that's the average of your Y's minus B, the thing you just figured out, times the average of your X's, which they give you here. They give you all this stuff. You're just plugging it into this formula. And then there is the equation of the regression line. Okay. And you'll have these formulas tomorrow to work with too in case there's a problem like that. Let's look at number 17. Well, this one says, what percentage of the variation, whoa, percentage of the variation, that looks like r squared, doesn't it? It sure does. That reminds me of r squared. But darn, they don't give us r squared, do they? But they do give us r. So maybe we could square it? Bam! There it is. That's what you're going to do. To get this answer, you're going to get, what is it? It's negative 0.71 squared. Okay? So there's your answer. Let's look at the last one. Now the answer key on number 18 starts to talk about lurking variables and confounding relationships in variables, which doesn't seem very fair because we haven't really covered that. I think that comes up a lot more in the next chapter. But what I'm looking at is, look at R. It's not very strong, okay? And only 50% of the variation is accounted for by the least squared regression line. So I might tend to say no based on these values, the ones that we were working with during this chapter. Okay, there it is. And I will see you tomorrow. And, send me a Remind 101 if you have any additional questions. So, there it is, and I am out.